Hello guys, I am going to discuss about the topic circular queue presented by me myself and Sai Nikita. Circular queue. We are going to discuss about what it means. Circular queue is the extended version of regular queue where the last element is connected to the first element, thus forming a circle-like structure. You can observe in the figure given below how it works. Here we are going to discuss about the circular queue solves the major limitation of the normal queue. In a normal queue, after a bit of insertion and deletion, there will be non-usable empty space. You can see below, it is given in the figure. Here, indexes 0 and 1 can only be used after resetting the queue. Deletion of all elements, that is deletion of all elements. This reduces the actual size of the queue. You can see in the image, that is DQ. Okay. Now we are going to see how circular queue works. Circular queue works by the process of circular increment. That is, when we try to increment the pointer and we reach the end of the queue, we start from the beginning of the queue. Circular queue operations. We are going to see about the circular queue operations. The circular queue works as follows. Two pointers, front and rear. Front track the first element of the queue and rear track the last element of the queue. Initially, set value of front and rear to -1. Now the next insert and delete functions will be discussed by Sai Nikita.
Now let us talk about the first function, inserting an item in the queue. Here are the parameters. Item is the only parameter here. It is an integer value representing the element to be inserted into the queue. Let's talk about functionality. It first checks if the circular queue is full by comparing the current number of elements with the predefined size of the queue. If the queue is not full, it calculates the next position for the rear pointer using modulo arithmetic to ensure it wraps around the circular queue. The item is then inserted into the position pointed to by the updated rear index. Finally, it increments the count to reflect the addition of new element. If you look in the code, this is the function insert. First, we have checked if the queue is full by checking if the count is equal to size. If the queue is not full, then we are going to increase the index value by performing the operation rear is equals to rear plus 1 percentage size. This helps us to increase the index value and hence the item can be added in the next index. Let us look at the picture here. This is the empty queue. By performing this operation, we can add the first element and second element and so on. And in the last picture, we can see that the array is full. Now let us talk about the next function, delete. It checks if the circular queue is empty by verifying if the count is equal to 0. If the queue is not empty, it retrieves the element at the position pointed by the front index and stores it in the variable element. The front pointer is then incremented using modulo arithmetic to ensure it wraps around the circular queue. It decrements the count to reflect the removal of the element. Finally, it returns the value of the removed element. Let's look at the function delete. Here it is checking if the count is equal to 0, which says that the queue is empty. If it is not empty, then let's consider the element as the front of the circular cube. Here we are incrementing the front by performing the operation front is equals to front plus 1 percentage size. This helps to increase the front value, front position, and hence the element will be deleted. Let's look at the pictures here. Here the element at index 0 and 1 got deleted, and once it is deleted, if you want to add an element, it is going to be added at index 0 and then at index 1. This is how circular cube works. Thank you for listening.